Finally, we talk about the SP hybridization. In the SP hybridization, compounds that undergo that are usually diagonal compounds forming the bond angle of 180 degrees. Now, how is SP hybridization formed? To form the SP hybridization, one of the two s orbital will hybridize or mix with one of the 2p orbital, and that will give us an equivalent of 2sp orbital. Once again, look at one of the 2s orbital mixing with one of the 2p orbital, giving us an equivalent of what? 2sp orbital. Now, did you notice that out of the 3 degenerate p orbitals, only one is used in SP hybridization, which simply means that 2 of the 2p orbitals are unhybridized in this case. And of course, if that is true, we should be expecting that compounds that undergo SP hybridization should be having 2 pi bonds, as already discussed from sp2 hybridization, whereby each of the pi bond comes from the unhybridized p orbital. Now we are going to look at an example of compounds that generally undergo sp hybridization. We talk about the alkyne. Now we have an example, ethyne. How is the ethyne molecule formed? Now watch carefully the ethyne molecule. Do not forget that we said that the hybridized orbital formed in sp hybridization are how many? 2 of them. So in the case of ethyne molecule, 2 carbons are found there. And now each of the 2 carbons possesses 2 sp hybridized orbitals. So if this has 2 sp hybridized orbital, this has 2 sp hybridized orbital, altogether there will be how many? 4 of them. Now, if there are actually 4 of the 2 sp hybridized orbital, what happens here when this carbon is linking with this carbon? This carbon will donate 1 of its sp hybridized orbital. This will donate 1 of its sp hybridized orbital. They will overlap axially to give us a sigma bond. That is a strong bond. Once again, don't forget, when hybridized orbitals are used to form bond, the bond is a strong bond called what? Sigma bond, which is usually single. Now we move on. How then is these 2 bonds formed? These 2 bonds are pi bonds. They are formed from the unhybridized p orbital. Remember, we said that in sp hybridization, there are 2 p orbitals that are unhybridized. So this carbon has those 2 p orbitals. This one also has those 2 p orbitals. So during the linking, the catenation of this carbon to carbon, this one will donate 1 of its p unhybridized orbital. This will donate. This will also donate the second unhybridized orbital. This will also donate, and they will overlap laterally to give you what? The pi bond. So do you see here we have 2 pi bonds here. These 2 bonds are formed from pi bonds, making alkynes very much susceptible to electrophilic attack addition reaction. How is these hydrogen atoms then linked to the carbons? Remember, this carbon had used 1 of its what? sp hybridized orbital. This one has also used 1 of its sp hybridized orbital. And remember, in the ethyne molecule there are 4 sp hybridized orbital, 2 from here, 2 from here. So if this carbon has used 1 and this carbon has used 1, 2 will be left out of the 4. Those 2 will now provide the site for hydrogen to link to the carbon, which is the single bond that attaches hydrogen to the 2 carbons, giving us the ethyne molecule. All in all, can you see something here? The total number of single bonds we have are 1, 2, and 3. While the double bonds we have are 1 and 2. That is, the sigma bond are 1, 2, 3, while the pi bonds are 1 and 2. We have some other compounds that undergo SP hybridization, the nitrites. There is a functional group C triply bonded to nitrogen. An example of a nitrite is ethanol nitrite, which has this molecular structure. And so that is all about hybridization. We can now see clearly what makes it possible for carbon to catenate.